Hello friends, today we solve problem on graphical analysis. So here is a question. The AT diagram for the linear motion is shown. In question they give AT curve. Construct velocity time diagram. So they ask to construct velocity time diagram and displacement time diagram. Means VT curve and XT curve. Okay, assuming that the motion start with the initial velocity. In question they mention the motion start with the initial velocity 5 meter per second and from starting point means start from origin. So they say that the initial velocity of the particle is v naught is equal to 5 meter per second. Okay, and x naught is equal to 0, and this is our AT curve. On y-axis acceleration, on x-axis time. Okay, so we have to construct velocity time diagram and displacement time diagram. So let's start with the solution. So from acceleration we have to construct VT curve and XT curve. So from acceleration we have to we can find out new velocity of the particle and new position of the particle using formula Vf is equal to Vi plus area under the AT curve, or for the position Xf is equal to Xi plus Vi into T plus area under the AT curve into T minus Tg, where T is the time interval and Tg is the x coordinate or axis of the center of the given shape. Okay, or Xf is the final position of the particle, Xi is the initial position of the particle, and Vi is the initial velocity of the particle. So start with the solution. So we first construct VT curve. For VT curve we have formula to find the new velocity of the particle. Vf is equal to Vi plus area under the curve AT. Okay, so let's start with the solution. So we have to find the velocity when t is equal to 0 seconds. We have to find the velocity when t is equal to 6 seconds. We have to find the velocity when t is equal to 12 seconds. Okay, so first start with the first. When t is equal to 0 seconds. Okay, for t is equal to 0 seconds, V initial V naught is equal to 5 meter per second, because in the question they mention assuming that the motion start with the initial velocity 5 meter per second. Okay, now second, when t is equal to 6 seconds. Okay, so we have formula Vf is equal to Vi plus area under the curve. So here motion from we find velocity when t is equal to 6 seconds. So we consider motion from 0 to 6 seconds. So motion from motion from 0 to 6 seconds. So here initial velocity Vi will be V naught, because we start the motion from 0 second. So V naught is equal to 5 meter per second. Okay, and area under the curve. If you see this curve, this graph, it is a simply right angle triangle. Then the area of the right angle triangle will be base half into base into height. So here base is a 6 and height is a 1. So just simply substitute Vf or V6 is equal to V0 plus half into base is equal to 6, height is equal to 1. So V0 is equal to 5 plus half into 6, we get answer 8 meter per second. So velocity of particle when t is equal to 6 seconds, v6 is equal to 8. Okay, when t is equal to 0 second, v0 is equal to 5 seconds. Okay, now the third point, when t is equal to 12 seconds. When t is equal to 12 seconds, so here we consider motion from 6 to 12. We can consider motion from 0 to 12. At that time, we have considered the initial velocity v0 and the area under the curve will be this addition of these two triangles. For simplification, we consider this motion from 6 to 12. At that time, the initial velocity will be v6, not v0. Okay, so we consider v6 will be the initial velocity plus this area under the curve. Okay, so we consider motion from 6 to 12 seconds. So for motion from 0 to 6 seconds, initial velocity will be v6, not v0. Initial velocity will be v6, which we get 8 meter per second. Okay, then we use the formula that Vf is equal to Vi plus area under the curve. So V12 is equal to V6 plus area. Okay, so V6 is 8, area will be half into, it is a simply right angle triangle. The formula will be half into base into height. If you see here, the base of this triangle is 12 minus 6, that is 6, and the height of the triangle is 2. So 2 into 6. So we get answer is 40. So we get all the values. When t is equal to 0 second, v0 is 5 meter per second. When t is equal to 6 second, v6 is equal to 8 meter per second. And when t is equal to 12 second, v12 is equal to 14 meter per second. Now we have to construct vt curve. So time is 0, 6, 12. We get answer. First is a 5, 8, 14. Okay. Okay. So we know if AT curve is a straight line, okay, then VT curve will be parabola in nature and HT curve will be cubic in nature. So here for the motion from 0 to 6, AT curve is straight line with decreasing slope, negative constant slope. And for the time interval 6 to 12, it is a positive constant. So when t is equal to 0, velocity is 5. First point is here. Second, when t is equal to 6 seconds, the velocity is 8. And the third is when t is equal to 12, velocity is 14. And the nature of curve will be parabola. Okay, because in AT curve it is a straight line. So in VT curve, the nature of curve will be parabola. So here slope is positive but it is decreasing. So we have to draw decreasing curve. So decreasing curve will be parabola in nature. Okay, then from 0 to 6 it is a constant positive slope. Then nature will be parabola and we have to draw decreasing function curve. Nature is parabola. So we get VT curve. In question they also ask to find the xt curve, that is displacement time curve or position time curve. So let's start with the displacement time curve or position time curve. For the xt curve, from acceleration time curve we have to find the position time curve. The formula is xf is equal to xi plus vi into t plus area under curve at curve into t minus tg. So here xf be the final position of the particle, xi be the initial position of particle, vi be the initial velocity of the particle, t be the time interval, area under the curve into t minus tg, or tg is the x coordinate of the shape, given shape, x coordinate of the centroid of the given shape from the where we start the time interval. Okay, so let's start. So first we find the x naught, vx, v6 and v12. So, x naught, x6 or x12 when t is equal to 0 second. Okay, so in question they mention the particle start from starting point, which what they say start from starting point means x naught is equal to 0 meter. So when t is equal to 0, x naught is equal to 0. Now we have to find what is the position of particle when t is equal to 6 seconds. So we consider the time interval from 0 to 6 seconds. So we consider motion from 0 to 6 seconds. Okay, for motion 0 to 6 seconds, xi will be x naught, vi will be v naught, time interval is 6 minus 0, that is 6 seconds. Area under the curve, it is a right angle triangle, we can find out the area and this area of this right angle triangle. The last one is the tg is the x coordinate of the centroid of given shape where we start the motion. So we start the motion from the 0. Okay, for this time interval 0 to 6 we start the motion from the 0 and we have to consider x coordinate of this triangle shape centroid. So centroid of the triangle, right angle triangle, will be here h by 3 from base, yes, b by 3, sorry, h by 3 or b by 3. Okay, we have to consider just only x coordinate. Okay, we also consider where we start the motion from the 0. So we have to consider from the 0. For this triangle the centroid is here g2. Okay, the h by 3 from the base, but in this situation we consider motion from 6 to 12. So our initial point will be 6 when t is equal to 6. So we have to consider this centroid from this point. Okay, so here we start the motion from the 0, so we have to consider tg from 0. Okay, the tg is equal to h by 3. So just write down xi is equal to x naught which is equal to 0 meter, Vi is equal to V0, which is 5 meter per second. T is a time interval is 6 minus 0, which is 6 seconds. Okay, then area under the curve, which is just simply right angle triangle. Then Tg we have, it is the x coordinate of the center of the given shape. It is a right angle triangle we see in a diagram. The Tg is h by 3. Okay, so h by 3 is 6 by 3, which is 2 seconds. Okay, so now find out the x6. So x6 is equal to x0 plus v0 into t plus area under the curve, which is a right angle triangle. Base is 6 and height is 1 into t minus tg. 6 minus, okay, x0 is 0, v0 is 5, t is equal to 6, 3 into 4. If we solve, we get answer xf is equal to 30 plus 12, 42. We get xf here. Okay, now x6 here. Now we find out x12, that is when t is equal to 12 seconds. Position of particle when t is equal to 12 seconds. Okay, so here for the 12 second we consider a motion from, for x12 we consider motion from 6 to 12. Okay, we can consider motion from 0 to 12. That time we consider initial position will be x0, v0. For simplification we consider the motion from x6 to 12. So motion from 6 to 12. Okay, motion from 6 to 12. For the motion 6 to 12, the initial velocity x0, sorry, xi is equal to x6. We get answer, that is 42 meter. Then vi will be v6, because we start the motion from 6 second. Okay, v6 is 8 meter per second. Okay, then time interval t will be 12 minus 6, that is 6 seconds. Then last one is a tg. Tg is the x coordinate of the centroid of the given shape. Here the shape is a right angle triangle, and that for the right angle triangle the centroid is from h by 3 from the base. Okay, and h by, we have to consider just only x coordinate. Okay, but tg is actually where we start the motion. We start the motion from the 6, so we have to consider this much amount as a tg. This is our tg, and the tg will be 2h by 3. H by 3, h minus h by 3 is 2h by 3. Okay, so we get tg 2h by 3. H means 12 minus 6, 4 seconds. Okay, so let's find out x12. x12 is equal to x6 plus v6 into t plus area into t minus tg. Okay, so x6 is 42, v6 is 8, t is equal to 6, area will be half, base is equal to 6, and height is equal to 2 for this triangle. Okay, we have to consider this right angle triangle. Here base is 12 minus 6 is 6, and height is 2. Okay, time interval t is equal to 6 and tg is equal to 4. If we substitute, we get answer x12 is equal to 102 meter. Okay, 102 meter. Now we have to construct graph xt okay, when t is equal to 0, x is equal to 0. When t is equal to 0, x is equal to 0. This is our first point. Okay, then when t is equal to 6, x6 will be 42. So our second point will be this. This is our second point when t is equal to 6, x is equal to 42. Then our third point, when t is equal to 12 seconds, x12 will be 102. This is our third point. Okay, now we have to plot a curve. We initially see if AT curve is a straight line, then VT curve is a parabolic in nature, then XT curve will be cubic in nature. So we simply draw a cubic curve here. Okay, cubic in nature, cubic in nature. So we plot VT curve. Okay, we plot XT curve. So they asked to construct VT velocity time diagram and displacement time diagram. We plot both the curve, that is a VT curve here and the XT curve here. Okay, this is our final answer. Thank you. If you like my video, please like, share and subscribe our channel. Thank you.